Well, hello, my name is Chuck Sammons. I'm with the Ohio Geological Survey, and thank you for joining us today for our next Ohio Rock Talk, all about water in Ohio. This is part of our Earth Science Week celebration as we continue that through this weekend. So be sure to check out our website at geology.ohiodnr.gov to get more information about what we have left for Earth Science Week. We have a couple of special guests today. We're going to have Devon Goeller, who's a geologist here at the survey, who's going to talk about water basics, the water cycle in Ohio, aquifer types, locations, water uses, and a whole lot more information. Then after Devon is wrapped up with his part of the talk, we're going to have Eric Saas, who's program director for the H2Ohio program, which has been a very successful program so far, and hopefully with many more successful projects to come down the pipe. So I want to remind everybody that the chat is on. If you have questions or comments, you can post those in the chat. And my colleague Alyssa Yapel, who's producing behind the screens, and I will try to answer those questions or pass them along to our speakers. So with that, I think we're going to hand it over to Devon and have him get started.
All right, thanks, Chuck. Let's see here. So are we good? Can we see the right slide here? Okay. My name is Devon Goeller. I'm with the Division of Geological Survey, and like Chuck said, I'm going to be talking about the hydrogeology of Ohio. I'm going to start off with, how do we get our groundwater? Talk about precipitation, and then go into aquifer types, where you could find different aquifers throughout the state. Then I'm going to talk about how we monitor it here at the survey, and briefly touch about groundwater use and allocation. So roughly 42% of Ohioans rely on groundwater for domestic use. So it's pretty important we keep an eye on it, not only for that domestic importance, but also reasons related to economic development and mitigating environmental impacts. So a good place to start is Ohio's water budget. So on average, Ohio receives about 38 inches of precipitation annually. 10 inches of that becomes surface runoff going into streams, rivers, and lakes. 6 inches makes it to the saturated zone. 4 inches pass through that zone, back into the unsaturated zone through capillary forces, and is returned to the atmosphere through evapotranspiration. About a half an inch is pumped from wells, which is equivalent to about 1 billion gallons a day. Again, this is statewide average, so you could see some variability around the state depending on precipitation and other hydrogeologic conditions. So moving on to show distribution of precipitation. So on the left, see average annual precipitation kind of ranges from 30 inches a year to about 45. On the lower end, near Toledo and Lake Erie Islands, you get about 30 inches. And then in southern Ohio and northeast Ohio, you could have 40 to 45. Map on the right shows average annual snowfall. See, it looks a little different than the map on the left. There's this very isolated area in northeast Ohio. This area falls within Ohio's snowbelt and is subjected to lake effect snow events. I'm from Buffalo, New York, so I'm no stranger to lake effect snow. And I can tell you that a difference between a couple inches and a couple feet is just a few miles. So this snowfall is really important for aquifer recharge and stream flow as well. All right, moving on to how does that precipitation become groundwater? So the process of precipitation percolating through the unsaturated zone, moving past the water table and contributing to that saturated zone is aquifer recharge. So aquifers can either be unconsolidated material or consolidated rock. Unconsolidated material, the grain size can vary from clay or silt to gravel or boulders, and water occupies that empty space between those grains. For consolidated rock, see this figure down here, these are bedrock formations that have been fractured through faulting or other geologic forces, and water primarily exists and is transmitted through these fractures, and their productivity depends on how concentrated these fractures and how connected they are. Lastly, KARST. This is an important one for Ohio. KARST is a term used to describe landforms and aquifer characteristics. The aquifer is characterized by sinkholes, caves, springs, and they form in regions where carbonate rocks are chemically dissolved by water, forming these in large fractures and cavities. So this encourages rapid groundwater movement and in sometimes unpredictable ways. We'll talk more about KARST later on. So let's zoom out to see groundwater recharge at the statewide level. So see in Southeast Ohio, you see recharge rates of 0 to 4 inches per year. This is due to this area's steep topography, which encourages runoff, but also the shale and clay-rich geology of the area really inhibits groundwater recharge with being impermeable lithologies. Moving northwest into the glaciated region, recharge rates can be 4 to 10 inches a year. I also want to point out these river-shaped dendritic features here. These are glacier-related, very high rates of recharge from 7 to over 10 inches a year. We'll talk more about that soon. So now we're getting into aquifer types. I want to start with bedrock and do a little bit of bedrock history. Our bedrock record starts roughly 440 million years ago. At this time, Ohio was close to the equator, actually south of the equator, and it was covered by the shallow tropical sea. This resulted in a deposition of a variety of sedimentary rocks, including limestone, shale, and sandstone. So over the next 180 million years, the paleocontinent gradually drifted northward. The level of this tropical sea varied. So the changes in depth led to changes in the depositional environment, different sedimentary rocks seen throughout the state. And also, when that sea was absent, there are gaps within our geological record. So I briefly want to hit each age of rock here of exposed bedrock at the surface, starting with our oldest, Ordovician. So at this time, Ohio was 20 degrees south of the equator. And Ohio was covered by the shallow warm sea that I mentioned. Limestone and shale are the dominant exposed bedrock lithologies. Moving into the Silurian in western Ohio, northwest Ohio. It was dry at the beginning, but the sea returned in the middle, and it shallowed later on. So this led to the deposition of limestone, dolomite, shale, and some evaporites. Moving younger into the east, we have Devonian. So we're close to the equator now. During the middle of the Devonian, muddy sediments were deposited. There was also some volcanic activity and mound building to the east, led to the deposition of volcanic ash. Near the end of the Devonian, the sea became stagnant and these organic rich muds were deposited. You can see limestone, shale, some sandstone found at the surface here. Younger into the east, we have the Mississippian. Near the end of the Mississippian, the shallow sea, or the sea became more shallow. Some limey sediments were deposited, seas eventually retreated, and that led to kind of a thinly dispersed rock record. Then we have the Pennsylvanian. Ohio was a flat coastal plain around the equator at this time. Sea level fluctuated, so we have a wide variety of deposits from sandstone, conglomerate, shale, limestone, and some coal. And lastly, you have the Permian, the brown here. At this time, Ohio was kind of a coastal plain swamp, led to the deposition of sand and clay, which led to the formation of sandstone and shale. So I know I painted a picture with a broad brush here. I just want to kind of give a feel for how changes in paleogeography, changes in depositional environment led to the deposition of different types of rocks, and we'll now talk about how those rocks are which bedrock is suitable aquifers. So we talked about those Silurian limestones in west and northwest Ohio. These are some of the most productive aquifers in the state. Moving east and northeast, you get into bands of sandstone and conglomerate deposited during the Devonian, Mississippian, and Pennsylvanian, which can be suitable aquifers. And then we get into this light blue gray across the southern portion of the state. So this is shale-rich bedrock. We have shale-rich limestone on the southwest and shale-rich sandstone, the Permian that I discussed on the southeast. The shale severely limits groundwater availability, but luckily residents in these areas can depend on glacial aquifers to supplement their needs, and I will talk about that very soon. So on the last map, you can see that limestone bedrock can produce pretty high yields, and the karst features within that limestone can be a major contributor. Karst features occur when, like I said, when acidic water dissolves away parts of those carbonate rocks, limestone and dolomite. This creates voids and enlarges fractures, creates cavities, and this creates this internal plumbing system. So it increases the ability for groundwater to move through that rock more efficiently. And you see on this map, these red dots indicate sinkholes. These sinkholes have very high recharge rates, and usually there are other karst features present in that bedrock. And depending on the density and connectivity of those features, it could significantly increase hydraulic conductivity. This is obviously good for groundwater movement and aquifer recharge, but there's a caveat here. Historically, these sinkholes have been used for garbage dumps. This picture is from Bellevue in northern Ohio. You can see trash in there. And this isn't good because depending on how connected those sinkholes are with the water table, you could really risk contamination. So that is a downside. So if you recall that bedrock map from a couple slides ago, that shale-rich bedrock in the southern portion of Ohio does not provide a productive aquifer, but these areas can depend on glacial deposits for groundwater. Here's a map showing glacial deposits throughout the state, and on the left, figure showing ice sheet from the last glacial maximum, which happened between 18 and 21,000 years ago. You can see they line up pretty well. Just to break down this map a little bit, in the northwest corner, these light blues, these are lacustrine deposits deposited by glacial lakes, found primarily in the Lake Erie Basin. Moving southeast, you have these greens, which represent glacial till, which the thickest deposits are dark green. Lastly, we have this light beige, it's kind of hard to see. These represent outwash, sand and gravel outwash deposited from meltwater in front of glaciers. And these aquifers can act as primary aquifers when bedrock productivity is inadequate. So we'll zoom in on some of these features, get a close-up view. So starting with glacial complex. So these complexes are interbedded sand and gravel lenses and till. They're found throughout the state, and they make up landforms like moraines. And the yields in these glacial complex aquifers are controlled by the thickness and interconnectivity of those sand and gravel lenses. We have outwash, which is sand and gravel deposits originally deposited from meltwater coming off the glacier. However, the most productive glacial aquifer are these Berry Valley aquifers. These are either former waterways for glacier meltwater or pre-glacial rivers. These typically contain large deposits of sand and gravel. So where can you find these? Throughout Ohio. You see a map on the right showing productivity from these glacial aquifers. These dark blues represent more productive areas where yields are greater than 500 gallons a minute. Those rates are possible. Most of these are either pre-glacial river valleys buried with sand and gravel deposits or glacial meltwater valleys filled in with outwash. There is an exception, which is the H2Ohio Aquifer in Northwest Ohio that is under Ohio, Michigan, and Indiana. This is a thick glacial complex. Yields up to 500 gallons a minute are possible, but given the uncertainty associated with the interconnectivity of those sand and gravel lenses, which I talked about in the last slide, if you're interested in drilling a well in this area, test drilling is recommended to find those permeable deposits for optimal yields. So that is the Machino Aquifer. We also have the Taysbury Valley, Mad River, Great Miami Aquifer, Scioto River Aquifer, and Tuscaroras. So again, these are aquifers in areas of the state where bedrock aquifers aren't very productive. So moving on, switching gears, I want to talk about some groundwater irregularities, an area of interest in Ohio, and that's these flowing wells or artesian wells. So these flowing wells occur when a well is drilled into a confined aquifer where the potentiometric surface for that confined aquifer is above the land surface. So when you drill a well into this confined aquifer, puncturing this confining layer, water can be driven, this water is under pressure and can be driven up out of the well and spills out to the land surface. So you can see on this map on the right, they are in both sand and gravel and bedrock. So it's about 50-50. I want to focus on two clusters here. One group of bedrock flowing wells in Sandusky and Erie counties near Sandusky Bay, and a group of sand and gravel flowing wells closer to Northwest Ohio. I'll talk about each of these groups. All right, so the flowing wells in Northwest Ohio. So here we have groundwater in those sand and gravel lenses beneath confining layers of glacial till and lake clays. These sand and gravel lenses become thinner and more finer grained as water flows from the northwest to the southeast. So in the context of well hydraulics, you have a decrease in specific capacity from about 18 gallons per minute per foot to about 5. So you have this decrease in specific capacity, you have decrease in seepage velocity, increases the force potential of the groundwater. So you have pressure building, head pressure building, and when this potential energy builds high enough to overcome the force of gravity at the land surface, the wells can flow. Moving on to that group of bedrock flowing wells near Sandusky. So this is a confined karst limestone. It's covered by impermeable lake clays, and you have a recharge area near Bellevue. It has a number of sinkholes here. Remember I said earlier that these sinkholes have pretty high recharge rates. So when you have high amounts of precipitation in this bedrock high, up gradient, water flows towards Lake Erie, and the pressure builds, head pressure builds, and allows flowing wells to occur in this area. So this high hydraulic conductivity and interconnectedness of the solution features in this area to it causes the groundwater levels to respond pretty rapidly to precipitation. As you can see, this hydrograph from a well in Erie County. So over very short time spans, you could have significant increases in groundwater level, and it really varies from 40 feet below land surface to less than 5. There can and have been issues with flooding due to groundwater upwelling in this area. All right, now I want to switch gears and talk about how we monitor groundwater here at the survey. So we have a groundwater observation well network. There are 141 wells in about 3/4 of our counties. These require quarterly servicing where we take manual measurements, calibrate data loggers, download data, do other well maintenance, and there's other special tests and projects that go on with these wells. I will put a link in the chat here to our website where you can learn more about the program, look at wells, look at hydrographs, download data. A little bit of history for our network. So it started with our first well, H8 in Wyoming, Ohio. We still have this well in our network. So this program started back in 1938 when there were concerns with declining water levels in an industrialized area north of Cincinnati. There are similar issues or concerns in Canton the following year. This led to the Ohio Water Supply Board created in 1941 and the Ohio Water Resources Board in 1945. Eventually, the ODNR Division of Water took over a couple years later. And over the next decades, this network built. We got more wells, and it peaked in the 1970s with 145 wells in 83 of Ohio's 88 counties. You can kind of see the trend here. Kind of shows the benefits of installing this well. You have 1938 when it was installed. You have this declining water levels. At this time, there was a lot of manufacturing with World War II. War ended, and water use was backed off a little bit. And over the next 45 years, that trend increased about 90 feet to the mid-90s, where it has remained relatively static since. So we have these wells pretty much everywhere. We have them at water plants, factories, college campuses, front yards, agricultural fields, parks, basements, and government buildings. And you can see a couple of them here have this antenna on them. These are some wells that have telemetry. We have 17 of them in our network. We share them with USGS. This transmits data every hour. We service the other wells quarterly, where we process and publish that data to our website. But you could go on the USGS website anytime and see some groundwater levels. So just to see the anatomy of one of these shelters on top of our wells, we have a SDR gauge, a data logger powered by a battery, and a solar panel. Typically, on this data logger, we have a wheel and a metal tape that's wrapped around it that goes in the well with a float on one side and a counterbalance weight on the other. So as water level changes in the well, this float moves up and down, turns this wheel, and every hour a reading is taken. And we process this data to take the daily maximum depth to water level that you could find and download on our website. I want to briefly hit groundwater withdrawal, groundwater use. So the groundwater withdrawal program was created in response to a severe drought in 1987 and 1988. It went into effect in 1990, and this requires facilities capable of withdrawing more than 100,000 gallons a day to register with the ODNR Division of Water. So you can see in the figure on the right, shows groundwater use. You see the public takes up a good chunk of that groundwater withdrawal, with miscellaneous use, which includes water parks, recreation, dewatering projects, and we have mineral extraction and industry making up a decent chunk, but an overwhelming majority, goes to the public. So here's another figure. This data is from 2019, as was the last slide. So it just goes to show that all other sectors combined wouldn't overcome what the public uses, which is about 464 million gallons a day. So I just thought it was good to finish off with these figures. They were a good representation of the importance of groundwater, not only for the public, but multiple economic sectors. And I think it emphasizes the need to study, observe, and care for this resource. On that note, I think I'll pass it over to Eric.
Thank you. All right, I'm going to get my screen sharing going here.
Yeah, there we go.
All right, how's that? Well, I'm in the Division of Water Resources, and I work with our H2Ohio program within that division. I'm excited to talk to you all today about the work we do. Devon mentioned the groundwater withdrawal program, and we have that here also in this division. And I work with folks who do dam safety inspections and floodplain management as well. But today I'm going to talk to you about what we're doing at ODNR for water quality. We've heard about the tremendous resource of water quantity that we have in this state. And unfortunately, I don't know that we've done the greatest job of taking care of that over the last generations. So what we're doing here is really a bias for action and taking direct action to improve the quality of water in Ohio. If you had to describe our role in the H2Ohio program, ODNR's role, it's wetlands for water quality. So the H2Ohio initiative is actually, it's broader and bigger than just ODNR. We are one component of a statewide multi-agency, multiple collaborator initiative that's focused on prevention of contamination to water, restoration of ecosystem function to improve water quality, and then a heavy emphasis on dedicating resources to the science, research, and measurement of how our actions that we're taking are improving water quality, and how we can bring that back into an adaptive management framework to do an even better job. So you see here, Governor and First Lady, this H2Ohio initiative is the principal environmental program of the DeWine administration. And we've been very fortunate that we've gotten a lot of resources at ODNR and other state agencies to really move forward with rapidity the work that we're doing for water quality. So like I said, this is a collaboration. H2Ohio, really the power of what we do is rooted in collaboration. Here at ODNR, we meet regularly with counterparts at the Ohio Department of Agriculture, Ohio EPA, and Ohio Lake Erie Commission. And really, we've shaped the mission of our agencies to work together toward a mission of water quality. So some of the targeted priorities for the broader H2Ohio program: agricultural land management at ODA. So we look at the northwestern corner of the state of Ohio, Maumee River watershed and adjacent watersheds that drain to the western basin of Lake Erie. Unfortunately, in recent years, we've seen nutrient runoff coming off that part of our landscape, fueling annual harmful algae blooms in the western basin of Lake Erie. Same can be said for a lot of our inland lakes in Ohio as well. So what we're working on with the Ohio Department of Agriculture through H2Ohio is keeping the nutrients that are needed to grow crops on the farm field where they belong and out of our waterways. And that's through a variety of incentives for producers to plan better for how they're going to apply nutrients, to engage in best management practices like cover crops or variable rate application of fertilizer. And then skipping down to our counterparts at Ohio EPA, they're focused on improving the infrastructure, the physical infrastructure that brings drinking water to communities and wastewater away from communities. And really investing heavily in parts of the state that haven't had access to clean drinking water and quality wastewater treatment in recent generations. So then here at the Ohio Department of Natural Resources, we're invested in wetland restoration as an approach for improving water quality. And we look at that from the standpoint of natural infrastructure. So instead of pipes and culverts, what we're talking about is habitat restoration, ecosystem restoration that has a water quality focus. So how can we take advantage of the fact that wetlands and floodplains are nature's kidneys? You know, these are places where surface water, it's filtered, and these areas can act like a sponge, soaking up, slowing down floodwaters. We have some pictures here, some examples of some of the wetland restoration work that we've been able to put on the ground so far. Our program was kicked off in 2019, and we're fortunate that at this point we have around 10, approaching a dozen completed wetland restoration projects across the state. You can see Brooks Park here in the upper left-hand corner. That's adjacent to Buckeye Lake, filtering in some of the water that comes into the lake from Murphy's Run. Oakwoods Nature Preserve in Hancock County, a large wetland restoration involving a lot of vernal pools and the ability for a nearby stream to overtop its banks and flow into restored floodplain. We have our Van Order Wetland and Forest Restoration, adjacent, actually part of Maumee State Forest, restoring some former cropland back into wetland in the Oak Openings region. And then we have our Forder Bridge floodplain reconnection. This is a sort of a passive treatment train approach where agricultural drainage has a chance to settle out in a series of pools before it connects with the Maumee River. So that, the other thing about wetland restoration is that not only does it have this water quality feature to it, but there's a lot of other reasons to like wetlands and to be interested in wetland restoration. And we look at that from our program as delivering co-benefits, whether it's recreation or habitat for threatened and endangered species. There's plenty of other reasons to invest in this kind of ecosystem restoration. So right now, here's kind of a dashboard of where we are with ODNR's H2Ohio program at the moment. We have actually at this point a little over 60 individual wetland projects, mostly focused in the Maumee River watershed, Western Lake Erie Basin, but increasingly now spread throughout the state as we're able to identify opportunities in the central Lake Erie Basin. And now we're going to be investing $5 million in projects in the Ohio River watershed. So the watersheds that drain south in the state. So to date, we've allocated about $64.5 million to support this kind of wetland project implementation that I'm talking about, and we really couldn't do it alone. As I mentioned earlier, collaboration is a cornerstone of H2Ohio, and the way that we get this work on the ground quickly is to work with conservation partners. So we identify folks like Ducks Unlimited or the Nature Conservancy, Black Swamp Conservancy, Soil and Water Conservation Districts, Parks Districts, and these are the people who we work together with to get the wetland restoration projects put on the ground. They help us identify quality projects and they help us implement those. So we have 104,000 acres of watershed that's currently filtered by our projects. And our program involves either the creation, restoration, or enhancement now of over 8,000 acres of wetland. Another thing that's worth pointing out is this is not just publicly owned land that's involved in our program. We've also incentivized enrollment in the Lake Erie Conservation Reserve Enhancement Program, putting a little bit of icing on the cake to encourage private landowners in the Lake Erie drainage to put in wetland restoration and wooded riparian buffer practices on their property. So we actually have now around 141 projects that we have incentivized into the Lake Erie Conservation Reserve Enhancement Program in that Lake Erie drainage. Over 20,000 trees and growing at this point have been planted in the buffers around these restored wetlands. And I'll talk about this a little bit more in coming slides, but we've taken a little bit of our implementation funding and we've established a monitoring program to track the effectiveness of the projects we're putting on the ground with respect to water quality. So you can see here, this is kind of the distribution of projects that we have right now. They're clustered there mostly along Lake Erie and in that northwest corner of Ohio, but spreading outward. We now have 29 counties that have an H2Ohio project, and that'll be growing here in the very near future. Lots of different types of wetlands can contribute to a water quality benefit. And so our program actually involves a diversity of types of wetland restoration. We have flow-through wetlands where there's kind of a defined inflow and outflow from the wetland. We have coastal wetlands along Lake Erie, where historically diked coastal marshes are being reconnected with nearby drainages that go into Lake Erie or with Lake Erie itself through the installation of fish passage and water control structures, which also enhances the capability of managing those systems for a variety of factors, including water quality. We have floodplain wetlands where a stream or river, when the flow increases, can spill out onto the landscape and deposit some of the nutrients that are flowing downstream. And then we have more isolated wetlands, wetlands that have more distributed inputs, maybe a stronger groundwater connection than necessarily a surface water connection. So just some examples of the flow-through wetland restoration projects. I mentioned Brooks Park earlier. This project is is right on the shore of Buckeye Lake here in East Central Ohio. And our Forder Bridge project, the flow-through passive treatment train. Examples of our coastal wetland projects, we have the McGee Marsh Turtle Creek Bay wetland reconnection here, where a drainage that goes to Lake Erie, Turtle Creek, can connect with Lake Erie Coastal Marsh through the installation of these water control structures. And then, as I mentioned before, another kind of side benefit there is being able to manipulate water levels in these coastal wetlands can help with the management of invasive species, drown out Phragmites using these water control structures, and also can be managed to intercept water flowing through Turtle Creek when there's a heavy nutrient load. We can bring that into the coastal wetland to filter and slow some of that stream flow. Some of the examples of isolated wetlands, that includes our Fruth Outdoor Center wetland restoration in Seneca County. This was actually our first project to be initiated and our first project to be complete in our H2Ohio program. We're proud of the work that Seneca County Parks did on a former camp property there, actually turning a soccer field that wasn't getting a lot of use into a productive wetland. Floodplain wetlands. So the prime example in our program right now is the Red Horse Bend Preserve along the Sandusky State Scenic River. This is a nearly 100-acre floodplain that was formerly cropped and was getting flooded out regularly. So this has been reconnected with the Sandusky River and now has the ability to absorb those flood pulses coming down the river system. So when we look at our wetland work that we're putting on the landscape, it's important for us at ODNR to answer the question, is wetland restoration a cost-effective method for mitigating nutrient loads to water bodies in Ohio? And how can we maximize that priority that we have for our wetland restoration program? What types of designs, what types of situation works best when it comes to wetland restoration with a water quality focus? And we're accountable for the work that we're doing and for the dollars that we spend and how to maximize that for a water quality benefit. So we've connected with the Lake Erie and Aquatic Research Network, an academic consortium of what I would just say is the dream team of scientists who work on water quality and hydrology, soil science. And we've had them all come together and help us develop a methodology for monitoring the performance of these wetland restorations and providing feedback into our program. So you can see here we have researchers from an array of Ohio academic institutions, all working in a coordinated effort to track the performance of our projects. They've, in short order, put together an over 100-page monitoring program that can be picked up and applied anywhere. Kind of a standard operating procedure for monitoring wetlands in terms of nutrient reduction effectiveness. And we look forward to what we're going to learn from the Lake Erie Aquatic Research Network. And I will wrap up my portion of the presentation here today, and I'm going to make sure we have time to address some questions from the audience.
All right, thank you, Eric. Thank you, Devon. We do have a couple of questions. For you, Eric, with regards to private landowners, possibly being assisted with creating a wetland, how could someone find out if their property perhaps once did have a wetland on it? And are there indicators? And I guess I'll throw this to Devon as well. Are there ways that we can find out if a property had a wetland on it, and if so, how do we do that? And does that play a role in how that wetland might be restored?
Yeah, I mean, one of the telltale signs of a parcel that used to be a wetland is the presence of hydric soils. So the soil type can be an indicator of whether that area, maybe prior to being tiled, used to lay wet for portions of the year. There's actually a web soil survey, an online mapping tool that folks can use to look up their property. You draw a polygon on there with your cursor, and it'll show you the underlying soil types. And so that gives a pretty clear indication if there's hydric soils there, then that area wants to be a wetland.
Well, I know that, up in the northwest, north central part of the state was once an area known as the Great Black Swamp. And I think many of the H2Ohio programs, projects, I should say, are being developed there. Devon, can you talk just a little bit about the geologic history of that area and why, if someone goes up there, you're going to see a lot of really dark, rich soils. Why is the soil so dark and rich up there? I think you need it.
There we go. Yeah. The northwest portion of the state, obviously very flat. So that area was flattened during the last glacial maximum that I mentioned about 20,000 years ago. And when it left these lake clays on top. So you're looking at fine grain clay deposits on top. We mentioned that with, briefly discussing aquifer types in that area, those glacial complexes that are kept by these impermeable layers. So yeah, I think kind of that stagnant, organic rich mud that's deposited off these glaciers. I don't know if Eric, you want to add to that, the superficial deposits there.
Yeah, well, I mean, great effort has gone into draining that part of the state and in previous generations to make it very productive agriculture. And the organic matter in the soils, it does lend itself really well to crop production. And what we're trying to do is not necessarily restore the entire Great Black Swamp. That's not part of the mission here, but there are parts and pieces of it that can be brought back, and the ecosystem functions associated with those areas can be brought back. One of the things that's pretty stunning is that Ohio has lost over 80% of the wetlands that used to exist in this state prior to the prior to the development of the state, basically. And so, we really have a missing ecosystem function, large scale on the landscape. And that's one of the missions of H2Ohio at the Ohio Department of Natural Resources, is to bring back important parts of that.
Okay, we have another question that came in. Will H2Ohio initiate projects to treat acid mine drainage in the future?
That is something we have an eye to be candid with you. When we look at types of water quality issues across the state, we can think about it in terms of the green water, which is the harmful algae blooms, the toxic conditions in some of our lakes. We can look at it in terms of the gray or the black water from failing home sewage treatment systems or failed wastewater infrastructure. And then there's the orange water. There's the battery acid AMD, acid mine drainage, in our southeastern Ohio streams. All of these things are visceral water quality problems. Governor DeWine describes this as a moral imperative to fix our water quality, and I don't think you could argue with that. When you see the conditions like these across the state, we do have an existing program at ODNR in Division of Mineral Resources Management that works to address acid mine drainage, but I feel like there might be a role for additional investment in that particular problem.
So another question, what can average homeowners do? Let's say you don't have enough land to develop your own wetland on that land, but what kind of things could you do as a homeowner to maybe help with the water quality in your area or on your property? What kind of steps could you take?
Yeah, when I look at conserving the resource that we have, just last night I was in my backyard doing some maintenance on my rain barrels. That's something that you can often work with your local soil and water conservation district. I know here in Franklin County, there's an incentive program for putting in rain barrels. And that's one way we can slow down that flood pulse, that stormwater flow as it comes off your property, and collect that water, reuse it in your garden, or when it's been dry for a period, you can drain down that rain barrel and have it ready for the next storm event that comes through.
And Devon, how about on GeoSurvey's side? What kind of tools and services can GeoSurvey offer to assist property owners with their groundwater and wells?
Well, we have a well database that you could, if you're unsure if a well is on your property or you want to learn more about your well, if you have a property that you bought, you want to learn more about your well, we have a well database where you could search your address and find it. Also, if you're interested in drilling a well, you could see that database, look up other well logs in your area to see where groundwater is being encountered, how deep these wells typically are, what kind of rates, how productive that aquifer is in your area. So there's a bunch of different things within, for GeoSurvey if you're interested in drilling a well. We also have fact sheets for what to expect, how well do you know your well, things like that. So yeah, not only do we have our observation well, our network, but there's also a much larger database of wells throughout the state.
Okay. Well, I don't see any other questions that have come in, so I think we're about 50 minutes in now, so I think we're going to wrap things up. I want to thank both of you, Devon and Eric, for helping out today and presenting what I think is just great information for Ohioans to have at their ready. And I encourage everyone to check out the Geological Survey website and the H2Ohio websites. Those have been posted in the chat. So Thanks again, and hope we see some folks out at the rest of our Earth Science Week events. Thanks to Alyssa helping out behind the scenes, and make it a great weekend.
Thanks for having us.
Thanks, guys.